Section 10.5 is called factoring special polynomials. Ooh, so very special in that they match one of these three formats. So what we're looking for, at least this first one, is called difference of two squares. Difference of two squares. And if you like abbreviations, you could even call it dots. I don't know it gives a way to refer to it. Difference just means subtract, and two squares means we're squaring numbers. So this is a number or an expression squared minus another number or expression squared. If it looks like that, then there's this very specific way to factor it, where it'll be a minus b times a plus b. Let's check this through FOIL. All right, we know how to FOIL. And this a and b they could be x's, they could be numbers, it could be really anything. This form should work anytime it's a subtraction of two numbers that are expressions being squared. But let's FOIL to check. A times a, that's a squared. A times b, that's plus ab. Negative b times a, negative ba, and negative b and positive b make minus b squared. Now with multiplication, it doesn't matter what order we multiply in. A times b is the same as b times a, but one's positive, one's negative, so the middle term cancels. That's why it's so important that one's positive, one's negative in the factoring, and also why it only works when it's a squared minus b squared. So one thing that's important, let me just put it up here, is that if you have a squared plus b squared, if it's not a subtraction, if it's an addition, that is prime. Cannot be factored. That this is only for a subtraction of two squares. Well, and sometimes people need convincing of that too. So let's pretend like, oh, well, maybe I don't believe Amy. Sometimes that happens. If I were to guess how to factor a squared plus b squared, maybe I'd do this, right? Because then I'd definitely get the a squareds doing FOIL. I'd definitely get the b squareds. But the only way to cancel the middle and to not have a middle term when we're doing our FOIL is for one to be positive, one to be negative. So this isn't going to work. When we do FOIL, we get a squared plus ab plus ba plus b squared. So this would be a squared plus 2ab plus b squared. Y'all see that? So we're always going to get a middle unless we can do it as a subtraction. But what I just did up here is actually one of these other forms. So if you see this kind of form where it's a squared, it starts with an a squared and it ends with a b squared, but there's something in the middle, you can sort of do like a guess and check and just see if, well, let's see what happened if I would add them and square it and see if you get that middle. It's always going to be 2 times a times b. If there's a subtraction in the middle, it's the same thing but with a minus. All right, so those are our special forms. Let's do some FOIL, but this time with some numbers in there, right? So it's sort of like the two examples I just did, but instead of a and b, we actually have numbers. So example 1, expand each expression. That just means FOIL. Or if you love box method, that's valid too. I'm just going to do FOIL. So 5x times 5x is 25x squared. 5x times 3 is plus 15x. Negative 3 times 5x is minus 15x. And then negative 3 times positive 3 is negative 9. All right, so that's the FOIL. But now we got to simplify. Oh, positive 15x and negative 15x cancel. So anytime you have one positive, one negative, that's this difference of two squares. So we get 25x squared minus 9. So that's the expanded version. So this is something we did, before this class, ideally just using FOIL. So what we're trying to do now is take this and go backwards. So the going backwards, the factoring, we're going to think about, well, what squared makes 25x squared? Well, that would be 5x. So 5x quantity squared makes 25x squared. And then what squared makes 9? Well, that would be 3. And so the factoring, if you look up above, was 5x minus 3, 5x plus 3. All right, so that's how we're going to think about it, as a subtraction of two things being squared. That's what it means to be difference of two squares. And we'll do more practice with this, but that, hopefully makes sense for our first one. Now, hopefully we remember that exponents do not distribute over addition, right? We cannot just do 7x squared and 2 squared, never works. Instead, you have to write it out as 7x plus 2 times 7x plus 2, and then do FOIL or box method. So FOIL, I get 7 times 7 is 49x squared, because x times x. 7x times 2 is plus 14x. 2 times 7x is another plus 14x. And then 2 times 2 is plus 4. So we do get the 7x squared and the 2 squared, but there's always this middle piece happening. In this case, it's 49x squared plus 28x plus 4. So this is its factored form. Or not, other way around. This is its factored form. This is its expanded form when we did the multiplication. If we wanted to go backwards and factor it, one thing we might notice is that it does start with a perfect square. 49 is 7 squared. We almost always have an x squared to begin with, but 49 is a perfect square, and 4 is a perfect square, 2 times 2. So what this middle ends up being is 2 times a times b, if you look at this up here. So if you multiply this times 2, that's the 28x. What I tend to do is, if I see these perfect squares, I just sort of do guess and check. I write it out as 7x plus 2 and 7x plus 2, FOIL it, and see that it checks out. All right, so let's do some examples where we're actually doing the factoring from the beginning. X squared minus 16. So this is a difference of two squares. We can write it as something being squared minus something else being squared. That's all we mean by this a squared minus b squared, or difference of two squares, or dots if you want to abbreviate it. Once we've written it as a difference of two squares, it's just x minus 4 times x plus 4. A minus b times a plus b. A good way to check, so this is my answer, but let's check it. Of course, the way to check it is to do FOIL. So x times x is x squared. Then I get x times positive 4 is plus 4x. Negative 4 times x is minus 4x. Negative 4 times positive 4 is minus 16. The middle goes away, so I do in fact get x squared minus 16. So the great thing about factoring problems is that you can always check your answer by doing FOIL. All right, so that's difference of two squares. Well, let's look at this one. So we could do AC method on this, right? That is still a valid form. I'm going to lean more towards guess and check because I know I'm in this section where they say it's special polynomials. So we're starting with a perfect square of 2y squared. We're ending in a perfect square, 5 squared. So basically what we're asking is the middle the 2ab? 2 times this. Or just guess and check. Right? That was always an alternative to the AC method anyways. I'm just going to try 2y plus 5 times 2y plus 5, and see if we get to this, right? Because I can sort of see like, oh, well, it's 2y and 2y make 4y squared, 5 times 5 makes 25. Let's see if we get that middle. All right, well, we actually have to check. You can't just guess without the check. 2y times 2y is 4y squared. 2y times 5 is plus 10y. 5 times 2y is plus 10y. 5 times 5 is plus 25. So yeah, we get the 20y squared in the middle, or not squared, just 20y. When adding, the exponents don't change. Multiplying changes exponents, but adding never does. So it checks, so that makes our answer 2y plus 5, and I'm gonna write it in that perfect square version.